Hi everyone. A few people have reached out and asked for help on trigonometry. So I'm going to create a series of videos. I'm going to go through some questions and try and go into a little bit more detail as we go along. So we're going to discuss how do I read the question to actually identify what information is important, to identify the information that helps me draw a diagram, and to identify the information that might actually help me work out the problem. So these videos are quite deliberately in not any particular order because I also want to discuss how do I know when to use which strategy? How do I know when to use right angle triangles? How do I know when to use non-right angle triangles, etc.? So I'm not telling you which exercise these questions are from. They're all from your textbook. But we're going to discuss how you might actually make those decisions yourself. And hopefully these videos will give you some detailed examples that you can copy into your own summary journal with clear annotations that will help you when it comes to a test and an exam. So let's actually kick straight off into this question. And the first thing I always do is read the question for details and highlight the key information in the problem. So here's our question. Akira measures the angle of elevation to the top of a mountain to be 20 degrees. He walks 800 meters horizontally towards the mountain and finds the angle of elevation is doubled. What is the height of the mountain above Akira's position? So let's actually start highlighting. The first thing I would highlight here is angle of elevation. And the reason I highlight that is because I know that angles of elevation and angles of depression always come from the horizontal. So that could be really useful. We know that that angle is 20 degrees, but I'm also going to say it goes to the top of the mountain. He walks 800 meters horizontally towards the mountain. So that's kind of important. There's a few key parts there. We've got the distance, we've got the direction with horizontally, and also whether we're going towards or away from the mountain. A simple word change there could actually change this question quite significantly. He finds the new angle of elevation has doubled. All right, so that's what I'm going to leave in blue. Still at the beginning. What I would do next is highlight the key question. So what am I actually being asked to do here? I'm being asked to find what is the height of the mountain. And then the last thing I'll highlight, and I'll do this in a different colour, is to the nearest metre. So that tells me how accurate I have to be. So let's actually start putting those key things together. As I mentioned, it's an angle of elevation problem. So I know that there's going to be a horizontal in my picture somewhere. So let's actually start by just drawing a horizontal line. There's my horizontal line right there. Beautiful. Horizontal line. And we've got an angle of elevation to the top of the mountain to be 20 degrees. So let's mark some points. Let's say Akira was here, and we'll call Akira A. And the mountain is over here at M. And we want to find out how far is it to the top of this mountain. We want to find out what is the height of the mountain above Akira's position. Okay, so we're starting to label some stuff on here. Now that height compared to the horizontal is going to be perpendicular. They're going to be at right angles. And we know that the angle of elevation goes up from the horizontal 20 degrees. Cool, so what we've just created, right angle triangle, beautiful. And what you would probably do at this stage is you would stop and assess, can I work anything out from here? And the answer to that is no, I can't. I can't work out anything yet because I haven't got enough key information. I've got this length that I want to try and find h, and I've got an angle. But in all of our problems, we need to have two pieces of information before we can find a third piece. So we haven't got enough yet. So let's dig a little bit deeper into our problem and go to the next part. We know that Akira walks 800 meters to a second point I'll call that A2, and the angle of elevation has doubled. So this is now 40 degrees. Okay, so I'll put the extra information on there, and my brain starts going, right, well, I've created another right angle triangle. Here's another right angle triangle, but I'm still missing information in this triangle. This triangle doesn't, this extra second right angle triangle doesn't help me find H. But now I can see, I've also got this triangle. It's not a right angle triangle, it's a non-right angle triangle. So let's start taking some annotations here. So it's a non-right angle triangle. So my brain starts to say sine rule or cosine rule. And I better write the word rule. Also, I've got a right angle triangle, or I actually have two right angle triangles. But those right angle triangles make my brain go, okay, what about SOHCAHTOA? So these are sort of like the analysing parts that I have to do to solve these problems. Right, so since I'm in the analysing space, what my brain does now, well, I haven't really got enough information. What can I do? What extra information could I bring to this problem? What else could I find? I can actually do a lot of things here with my angles. If I know that this is 40 degrees and this is 90 degrees, then the angles in a triangle have to add up to 180. So 40 and 90 make 130, which means that this angle up the top would have to be 50 degrees. Cool. And I go, right, does that help me as well? Does that give me anything extra? Maybe not. All right, let's keep working. The angles in a straight line make up 180 degrees. So this is a straight angle here. So that means this angle would have to be 140. And I start to say, does that help me at the moment? No, maybe not. But in this right angle triangle, I'm starting to get a whole heap of extra information. Other bits that could help me solve this problem. And if I know that, again, I'm now of my non-right angle triangle, those three angles have to add up to equal 180. So if I put the 20 degrees and the 40 degrees together, then this angle here has to be 20 degrees. It's 20 plus 140 makes 180. Now that's really interesting that that's 20 degrees because it doesn't look like it at the moment. But that actually sparks a bit of knowledge in my head about isosceles triangles. So let's start writing down for our notes and annotations some of the key things that we've noticed. So, key thing I noticed, 1. Angles in a triangle add to 180 degrees. Does this help? And it might not, because we're just analysing the question. Number 2, straight angles equal 180 degrees. Does this help? And in my head, when I spotted that second angle, I've actually just worked out how I'm going to do this problem. Isosceles triangles have two equal angles and two equal sides. And that's the part that's actually helped me work out how I'm going to solve this problem. So I'm just going to redraw this, because now that I know that this angle and this angle are the same, I'm going to actually make them look the same. And if they look the same, it's going to be an isosceles triangle, or redraw that line. Something like this, where that's 20 degrees, that's 20 degrees, that's 800 meters. And if you know your isosceles triangles, they have 2 equal angles and 2 equal sides. This side must be equal to this side. So by playing with those angles and just trying a few different things, I've kind of got to a point where I've got an extra bit of information that will help me for this problem. I know that that side is also 800 meters. And hopefully when you spot that that's 800 meters as well, your brain ticks in and goes, now I've got my right angle triangle with 2 pieces of information that are going to help me find the third piece of information. Alright, so let's actually work through that now. We have a very complicated diagram now. I've got bits written all over it. And as soon as I get a complicated diagram, I tell myself, right, Troy, you can't handle too much information. What I'm going to do now is redraw a nice, simple diagram. So I'm going to redraw this nice, simple right angle triangle and put only the information I need on it. So I'm trying to find out what H is. I know that this side is 800 meters, and I know that this angle is 40 degrees. And I go back to my point, I've got a right angle triangle, so it's going to have something to do with SOHCAHTOA. So let's work through the process where we label the sides, opposite, hypotenuse, choose the rule, sine theta equals the opposite over the hypotenuse. Next step, substitute what I know. So I know the angle is 40, the opposite is h, and the hypotenuse is 800. And in this problem, I want to find out what h is. To find out what h is, I have to undo a divide by 800. And the opposite of dividing by 800 is multiplying by 800. So let's multiply both sides by 800. 800 times sine 40, and then break out your calculator. Obviously I'm not going to show this on the screen at the moment, I'm just doing it off to the side here, and I get 56.56. Right, this is a great point to reread the question and make sure you haven't left out anything that's really important. So let's go back and notice I highlighted this nearest meter right at the beginning. So rereading the question, yes, I've used the angle of elevation. Yes, I've found the height of the mountain, but I haven't answered to the nearest meter. Excuse my phone ringing. So let's now just simplify that. Round off to the nearest meter. This will be closest to 57 meters. And I've got the height of my mountain. You might want to even write the height of the mountain is 57 meters. You don't have to do that, and if it was a test, I'd probably try and save myself a little bit of time by not writing that, but all of my other notation's really clear. So how did I go through that? Highlighted the key information. I reread that key information while I was drawing a diagram. I then analysed my diagram and thought, what can I use? And the first thing I thought was non-right angle triangles. I thought about right angle triangles. They weren't helping me, so I then analysed the angles and the straight angles, and then I spotted that isosceles triangle. And that moment that I spotted the isosceles triangle was the moment when I went, haha, now I know how I'm going to do this question. And I'll work up from there. So don't be afraid to start a question before you know exactly what you're going to do. That's really important in mathematics. We give it a crack, we start working through it before we necessarily know exactly our approach. Okay, that's the first video.